Again, we are to solve for x, and we notice that we're going to have a problem here because we have 2 logs and then something else over here on the right side of the equation. We have the same thing in this next problem. So we're probably going to need to use the property that says that the log base a of x plus the log base a of y is equal to the log base a of x times y. A sum of logs can be written as a log of a product. That could be written either way. It could also be stated the log of a product is equal to the sum of logs. In this case, though, we're also going to need to use another property where we can get rid of this 2. And that property will be that the log of an argument raised to a power can be written as a product of that power and the log. In other words, I can take this exponent and bring it down front. Or if I have a factor out front, I can put it up in the exponent, which is what we'll do here. We'll have log base 2 of x minus 4 squared plus the log base 2 of 4 is equal to 6. Now we can multiply here because a sum of logs is equal to the log of a product. So we have the log base 2 of 4 times x minus 4 squared is equal to 6. Now we can convert this to its exponent form. That is going to be using our log form and converting it to its exponent form. As long as a is greater than 0, a is not 1, and x is greater than 0. So we'd have 2 to the 6th is equal to 4 times x minus 4 squared. 2 to the 6th is 64, so we'll have 64 is equal to 4 times x minus 4 squared. We could divide both sides by 4, and we'll wind up with 16 is equal to x minus 4 squared. We can square root both sides. Square root of 16 is the square root of x minus 4 squared. We remember that we want to be careful about using the plus or minus when we use the square root property here because of what it might do to the argument. And here then we'll have 4 is equal to x minus 4. We'll add 4 to both sides and we'll have x is 8. We won't use the minus because that'll give us x equal to 0, and we can't have 0 for x here because we'd have a negative 4. So x is equal to 8 is our solution. Here's another similar problem. Here we are set up to go ahead and write this as the log of a product. There's nothing multiplied down front that we would have to put up in the exponent. So we have the natural log of x times x plus 8 is equal to 9. This we could rewrite in its exponent form. E to the 9 is equal to... Now, we may as well go ahead and multiply this out because what we're going to wind up with is a quadratic equation. And if I was to rewrite this so that the x's are on the left and the constant term is on the right, I can see that this is setting itself up very nicely as a candidate for completing the square. I'll take 8 and divide that by 2 and square it, which would give me 4 squared, which will be 16. And that is what we will add to both sides. Now this factors as x plus 4 squared, and then we have e to the 9 plus 16. We will take the square root of both sides. Again, the square root property. We seem to be using that a good bit. And we'll have plus or minus e to the 9 plus 16 under a square root on the right. So we'll have x plus 4 equals. Now, we're going to want to think about this. When I write this plus or minus, what I'm going to wind up with here is a quantity that will be bigger than 4. The square root of 16 is 4. If I add something to that, it's going to be bigger. So this quantity is bigger than 4. So when I subtract 4 from both sides to get x by itself, I wind up with x equals minus 4 plus or minus this quantity. Well, if I use the minus, then I'm going to have a negative value here, and x can't be negative. I can't have the log of a negative value. But if I just have the plus, the square root of e to the 9 plus 16, and I ask myself, well, does that give me a positive value to plug in for x here? And yes, it would, because we've already decided that the square root of e to the 9 plus 16 would be greater than 4. And if I subtract 4, I'd get something bigger than 0. So there is the result.